been a long day.
We produced a podcast episode and we're pretty much running full tilt from morning to 2 o'clock. And then we just went and got wraps.
Quick little wrap for lunch. We were feeling kind of low before that.
Just flat.
Yeah.
So energy levels. We're thinking about our energy levels.
Yeah. We think about them more than the average person when we're recording these intros, because when you can't see someone, you have to really hear the energy in their voice.
People are sort of obsessed with energy. I think there was that languishing thing during the pandemic. And now I feel like everybody is a little more buzzed. I don't know. Do you feel like that?
Yeah. And I think everyone's got more plans than we've had in the past 3 years. And we're finding it hard to fulfill those plans. Like a full day at work means that I might have to cancel my evening plans.
Or a full evening of plans may have you maybe thinking about the next morning of work. Yeah. Yep. Yeah. So what a great time to examine energy levels, and how to, like, so many questions about energy, actually.
Like, what is energy? Is there something in our body that tells us we are low on energy, or is it just a feeling that we have?
We're talking about the energy of your life, like the pep in your step.
The gas in your tank.
Welcome to Eat, Move, Think. I'm Christopher Shulgin, executive producer.
I'm Jasmine Ratch. I'm managing producer.
Pretty excited about this one, actually.
Yeah, absolutely. I mean, I'm feeling high energy about it.
So our host, Shaun Francis, is interviewing
Dr. Martin Picard. He's a professor of behavioral medicine at Columbia University Irving Medical Center.
He is an expert in mitochondrial psychobiology. Well, I'm not going to give anything away because we get into this in the show, but mitochondria is the powerhouse of the cell, is the source of energy in the body. And Dr. Picard talks about how to get more energy, what energy is.
Can you even measure energy?
How to live your life so that you are in kind of a higher energy state. What really works, what doesn't. In conversation with Dr. Martin Picard of Columbia University, here's Shaun Francis.
Hello, everyone. I'm Shaun Francis, CEO and chair of Medcan, and happy to welcome Dr. Martin Picard to the show today. Dr. Picard, thank you so much for being here.
Thank you. My pleasure.
Tell me about the Picard lab. What happens there, and how did you get into studying the science of energy?
Yeah, well, energy is fundamental to what we are and to life. The the fundamental difference between a thinking, feeling, active, conscious person and a cadaver really is the flow of energy. The molecules are the same, the cells are the same, the organs, the bones are the same, but without the flow of energy, then we're just a bunch of cells. And we care a lot about understanding, what makes people healthy, what allows people to remain healthy for decades, right? And there are people who live up to like 100 years old without ever getting seriously ill, and there are other people who get sick every few years with something serious. What's the difference there, and what allows people to be resilient, to be robust, to be healthy for a long time? We don't know the answer to that question, but it's very clear from the research out there that the stuff that happens inside, not just the body, but inside the human mind, have an influence on what happens in the body and on, the health trajectories and how we age and so on. So my lab is a lab of mitochondrial psychobiology, mitochondria, and we'll talk more about that, I'm sure, or that those little components of the cell that transform energy. They take the oxygen we breathe in, the food we eat, convert that into usable, energy. And then that, keeps the light on in the body, keeps us warm. And then the psychobiology part, connecting the human mind and the subjective experiences with the biological stuff, the molecular stuff that happens in our cells and in the mitochondria. So that's what my lab tries to do. It tries to kind of work across boundaries. Scientists are trained in very specific disciplinary boundaries, so we try to work across those boundaries.
So when you say, I don't feel energized today, or I don't have energy, are we talking about mitochondria? Are we talking about a mental state? How do you define it?
Yes, it's a great question. So I wish we had a really good answer to that question, but we don't. So we don't really know what is the connection, whether it's a direct connection, right? Can we feel our mitochondria? Can we feel the amount of energy that's being transformed inside of our cells and of our mitochondria? We don't have a good answer to that. So maybe yes, maybe no. There's definitely a connection. And there's a few reasons why we know there's a connection between the subjective experience, right? The mental experience of having energy and the biological or physical reality of energy transformation in the mitochondria. One example is a group of patients that have genetic defects in their mitochondria. And those are rare conditions, but they show up in the clinic. They have multi-system disorders. Very often, the brain is affected, the heart is affected, the kidneys are affected, and the gut, the digestive system. And the main complaint that these patients have, they have all of these problems, but the main thing that bothers them is that they don't have energy. They feel tired all the time. And that's, as everyone knows, feeling tired can really take over your life. When you're really tired, it's hard to do anything else. So these patients that have a primary defect, often a genetic defect in the mitochondria, so they can't transform energy at the cellular level, the experience of this, the lived human experience, is that of fatigue and not having energy. So we know there's a real connection. Somehow we can feel what's happening in our mitochondria.
So I know when we're, for example, sick or fighting an infection, we also feel really tired or lack energy and maybe want to sleep more, or just can't, have zero desire to go do anything super aggressive. Is that connected again biologically?
Yeah, that's a great point. That's a great example. It is definitely connected. And in the immunology world, it's called sickness behavior. So sickness behavior is when you feel tired, you feel asocial, you don't want to engage with people, you want to stay in your bed. All of that collection of experiences and behavior, sickness behavior, is very powerful, and it's driven by the immune system. So when the immune system kicks in to fight a viral or bacterial infection, or to heal wounds, and then there's inflammation in the body, that signal is communicated to the brain, and maybe not just to the brain, but as a whole, the organism feels like this is costing a lot of energy. Turning on the immune system is really expensive. People have quantified this, right? What's the energetic cost of fighting, a virus or a bacterial infection? It's a lot. So probably as an evolutionary learned behavior, if you're going to spend a ton of energy fighting something and turning on your immune system, you better conserve energy. You better not go for a marathon, run a marathon, or engage in energetically expensive activities and interactions with other people. So all of that sickness behavior, you just feeling tired, wanting to sleep, is probably wired in, and something humans have learned, and other animals. This is conserved across the animal kingdom. When we're sick, we want to sleep, and this is probably adaptive, so that there is energy available for the immune system. And that all boils down to some constraints. Like, there are limits to how much energy we have, and if it's consumed very actively by one system, like the immune system, then the other systems kind of take a back seat, and then we feel tired, and that frees up energy for the immune system to do what it has to do.
Makes intuitive sense that my body is saying, don't run a marathon because I need all of your energy to fight this infection. But in a way, it's tricking our psychology, because I feel tired, even though I may be burning more energy fighting the infection. So how does that connect to times when I don't have an infection, yet I feel tired?
Yes. Yeah, you raise a really good point, because if you're fighting an infection, you're feeling really tired, there are probably some drugs that you can take that will completely obliterate the subjective experience of fatigue. Stimulants can override, that kind of information about the immune system is active, you better rest. You can do something, you can trick your body and your brain into thinking that you have plenty of energy just, by injecting or ingesting something. I think tells us that there's kind of an intermediate there. What's happening in the body that's feeding up and saying, like, you better rest and save energy. And then there's something else that, can modify whether you feel really tired or whether, like, you can get through it. And we all have experiences. Someone can tell you something, and in a few seconds, you go from feeling pretty energetic to feeling drained, right? Some like toxic comment or something you didn't want to hear, or the other way around. You feel tired, and then you get a fantastic email, a great positive news, or you see your beloved, and then all of a sudden you forget you're tired, and you feel energetic. So that we don't really understand. And there's probably many layers of regulation, that connect the biology to the subjective experiences, but there's something there that isn't fully understood scientifically.
Has that been measured? So before we get to that, why don't we talk about what exactly happens at the mitochondria level on a more layman's explanation of how that actually works?
If we want to trace kind of the steps, what brings us to life? It all starts with the sun. And, I don't want to just be, too loose here, but it's really true that all of the energy, every form of life on the planet, including, breathing, thinking, conscious people, the energy comes from the sun. And it's beamed down as photons, waves in non-material form. It beamed down to the planet. And then plants have this ability to take that energy and chloroplast, turn that into oxygen. And they use that energy actually to take carbon dioxide from the air and then react them together. And then in the process, they make starch, right? Wood or sugar and, fruits and everything and the food we eat. And then in that process, oxygen is liberated. In chemistry and in, quantum electrodynamics, oxygen really wants to be with carbon. So what the plant does is really difficult to do. It needs a lot of energy to rip off oxygen from carbon. So basically, that's what plants have learned to do. They split up carbon and oxygen, and then oxygen, then it's out in the atmosphere, and it longs forever to reunite with carbon. And that's where really, the energy is stored, in the separation of oxygen and carbon. And then what we do as humans is we eat the food, right, that plants have made. Or, plants made some food, animals eat the food, and then we eat the animals. Whatever kind of food you eat, you end up eating energy, carbon came from the sun. And then what we do is we breathe oxygen that the plants made. And then what happens in the mitochondria is that the carbon and the oxygen that were separated in a very thermodynamically improbable reaction or reunited in the mitochondria. And this is really the magic. And the way this happens is, for example, you eat a molecule of glucose, and then there's a few reactions called glycolysis that break the glucose into pyruvate, and then pyruvate enters the mitochondria. And then there's a series of reactions that happens there where electrons, one by one, are ripped off the carbon backbones of pyruvate. And then these electrons are shot up into what's called the electron transport chain. And this is kind of a series of proteins like a metal wire that's inside the mitochondria. And then the electrons just flow through, just like electric current, just like, current flows through the cable between the outlet and your computer. Flow of electrons through the electron transport chain. And there's a lot of energy there. Like there's enough energy in the cable from your computer to power your computer or your hair dryer, whatever it is. So all of this energy flowing through this little cable in your mitochondria is used to pump charge across a membrane. It harnesses the flow of electrons and the electron transport chain to charge mitochondria, just like little batteries. And then they can use that charge to produce ATP. A lot of people have heard about ATP, adenosine triphosphate, which is kind of the cellular energy currency. And once you have charged batteries, right, you can do anything. The same way that we use batteries to power laptops, phones and flashlights, your car, electric car. The mitochondrial batteries can be used for all sorts of things. So to make ATP, but dozens of other functions and making hormones and regulating other things in the cell. So they're definitely, much more than a powerhouse, but that's a big part of their role is to use their charge to make ATP.
And do you need that charge to make everything work in the body? Like, in other words, like your heart isn't pumping and you're not breathing without that charge.
Without the energy, the charge in the mitochondria, there's no heartbeat, there's no brain activity, there's no breathing, there's no digestion, there's no, liver, blood cell production, stem cells, like everything in the body works, in an aerobic manner, meaning it needs oxygen. And the reason it needs oxygen is because the mitochondria need to do their electron flowing, charge producing activities.
So biologically, are some people, better energy producers? And does age affect it?
So definitely there are people who, in their constitution have mitochondria that are better tuned to make a lot of ATP. Some people's mitochondria are, less tuned than this. Ability, to make energy is driven by stuff that you've inherited, right? And your genes from your mom and dad versus stuff that, you acquired through development, through were you physically active, right? Early in life, the kind of food you eat, whether now you're physically active. Something we know, for example, you can have two people who are sedentary, right? And then if both of them work out, you go from couch potato to training for a marathon. Both people, even if one starts with low mitochondria and low energy production capacity and the other starts with relatively higher, those two people can double their mitochondrial content, their mitochondrial mass in their muscles, for example, in response to steady exercise. And everything that makes you breathe harder means your mitochondria are working harder, because you don't need to breathe harder if your mitochondria are not burning more oxygen. So the body and the cells respond to this by making more mitochondria. So most people can double the amount of mitochondria they have just with behavior. So the majority then of differences between people, might be driven by the behaviors, the food we eat, and maybe, some psychological and psychosocial, factors that might trickle down to our mitochondria.
Are you saying that exercise effect, is that momentary, and does it then decline to some base level, or can it have more permanent impact?
Yeah, the body is wise. If you don't need something, you're not going to keep it around. So in response to exercise, within 4 to 8 weeks, you can significantly increase the amount of mitochondria that are there in your body. Then if you go back to being couch potato, the mitochondria are going to go. You're not going to keep them forever. There might be some memory, some plasticity. So mostly what we know is that there's a lot of malleability and flexibility.
In theory, someone who works out routinely, all things being equal, ought to have more energy for everyday activities than, say, someone who's completely sedentary.
Yes, there's very good data on this. People who move more tend to have more mitochondria.
And is there a difference between, just to be more specific on exercise, between cardio exercise and resistance training?
So cardio exercise, whatever, when that makes you breathe harder for long periods of time, is what stimulates the production of new mitochondria. That's called mitochondrial biogenesis. So mitochondrial biogenesis is very strongly stimulated by cardio exercise. Resistance exercise, you'll have a few hard breaths after your rep, but it's not going to trigger the same kind of energy needs, sustained energy need that then stimulates mitochondrial biogenesis. So you make much more mitochondria when you do a cardio exercise.
Now, where does sleep come into this? I mean, obviously, we don't get enough sleep, we're tired. I've also read that sometimes too much sleep can also be negative and make you tired. How does sleep factor in?
Of all of the human behaviors, sleep, it might be one of those that we know the least about. So there's a lot of gaps. We don't really know what the connection is between sleep and mitochondria. That's something we're interested in. And we're doing a study now where we bring people in and then they sleep here. And then while they sleep, we take blood samples. And then from the blood samples, there are white blood cells that are in circulation from the immune system. And then those cells have mitochondria. So then we can look at mitochondria and we can look at mitochondrial signals, because mitochondria talk to each other as well as making energy. So we can look at mitochondrial signals and mitochondria in the human body when you're awake, right? When consciousness is there and you're doing your daily thing. And then when you sleep, kind of consciousness leaves the body. And then you enter into this regenerative state that somehow brings us more energy. We don't know how that happens. We don't know how this kind of overnight rejuvenation that we experience happens. So that's something we're excited about, and others are also interested to understand.
And do you have a theory on it? Speculate it?
Mostly, I think in general, when we sleep, mitochondria have to do something that they don't do in a normal time. So the question we've been asking is, do mitochondria sleep as well? And then what does that look like? When humans sleep, the mind kind of shuts down, or at least the conscious part of it. And then you lose awareness of your surrounding, you lose awareness of yourself. The dominant, me part of the self goes to sleep and, goes away. And that might actually be what is restorative, regenerative. It's like entering into a very deep meditative state where the self is gone and, the ego is no longer in control of your biology. And then the biology can just be at its best and, regenerate itself. So those are ideas, and we'd love to do more studies on this, but yeah, so we don't know, but I have to think that mitochondria do something like sleeping, which we have to figure out, what exactly this is. And there's, a profound connection here, the human mind, consciousness and energy that we still need to crack.
So it's that link between the psychology and the biology, because if you are sleep deprived, you're going to feel, less energy, which must be having some effect on the mitochondria.
Yep.
But you're just not sure what that effect is yet.
Correct. Yes. We've learned maybe a little bit through experience, but mostly through like the scientific framework that we evolve in, that there's the mind and there's the body, right? And, there's the mental health and there's a physical health. But really those things, the deeper you look, the more interconnected you see that they are. We've talked about how energy is central to life and to mitochondria and to the ability of cells to just, survive. The mind, the human mind, and the subjective stuff that we experience could not exist without the flow of energy either. So really energy is what binds, right? There's the interface between the mind and the body is an energetic interface. And without that flow of energy, then, those two sides of the coin just, fall apart, but together. One can't exist without the other one. You can't have a mind without a body. You can have a body without a mind. And there's such, profound connections between human physiology, human biology, and what's going on in the mind. Like, you prepare for a meeting, right? You're going to give a little talk or you're going to, present something at a briefing meeting. Right away, your heart speeds up. Like nothing's happening. You're just thinking, oh yes, I'm going to have to present this to my boss. Right away, your heart goes from like 70 beats per minute to 90 beats per minute. Your blood pressure increases. You start to secrete hormones in the blood that cost energy. And then your palms start to sweat. You're diverting energy, right, from core organs to the periphery. And then the body starts to anticipate all sorts of things. It starts to effectively waste energy, on stress responses, and arousal physiology is really under the control of the mind. So, I think the mind controls metabolism in the body and controls a lot of functions. And how we feel is also very much influenced by what's happening in our biology. So it's really a two-way stream. And we don't know yet what the mechanisms are that allow us to feel what mitochondria are doing, how much energy there is available there and vice versa.
So someone who is in a more, I don't even know if this is a word, adrenalized environment. In other words, you're either seeking adrenaline or you're ambitious and always seeking out more, versus the Buddhist who might be in that Zen state. Is it conjecture to say, is there different energy levels between those two people, or is it just a perception?
I think objectively there is very likely to be an energy difference. If we can quantify these things, you can measure how much energy does a person consume, over a 24-hour period, or over, 1 hour period. And it's very clear that if you're, engaged in doing things, and especially if you're aroused and you're like fired up and adrenalized, you're using more energy than, the Buddhist monk. And there actually been studies where, you take someone who knows how to meditate, and you can take like an advanced meditating, Zen Buddhist monk, and then you measure how much energy their body is consuming, right? Just like sitting there with eyes open, chatting with someone. And then you say, okay, now go into the deepest trance you can. And then the monk just goes there and goes into this trance. The amount of energy consumed by the body can drop by up to 40%. For example, when you go to sleep, it never drops that much. Like it drops when you sleep, which is probably why it's restorative, right? Because the body is just burning less energy when you're asleep. But meditation seems like it can bring that level of energy consumption even lower than sleep, which is astonishing. So there is probably an objective difference between, the Buddhist monk and the adrenalized, fired up corporate executive.
So that's super interesting, because is the monk in the Zen state, storing energy in a way that might be creating a reservoir that they have for other activities? Or is it the corporate executive who's always at that peak state? Like, is it a good or a bad? I guess I'm trying to understand. People say meditation is good for you. They're not quite sure why. Is there any connection there?
So this makes me think about, like, during exercise, you breathe faster, right? You're burning energy faster. Is this a good or bad thing? So in the moment, you could say, well, if you burn energy faster, maybe you're going to deplete your reserves faster, right? But people who have an exercise routine, know that actually when you exercise, it doesn't drain you. It can actually bring you more energy, for the rest of your day and for the rest of your life. And there's cool science there that has emerged in the last few years showing that during exercise you consume more energy. Your heart rate increases, you breathe, faster, your mitochondria are consuming more oxygen because you're reuniting the electrons with the carbon and producing a charge, powering your muscles, powering your brain. So this is what happens during exercise. Now, after exercise, in the recovery phase, right, for the rest of the day and then the rest of the week and so on, it seems like people who exercise are actually more efficient. So then you can live the rest of your life at a lower cost. That might be where the health benefits of exercise are. This is probably, conjecture that this is the mechanism for why exercise is healthy. But I think there's a good chance that, it is at least part of the mechanism. Even though you waste more or you spend more energy during exercise, then it makes you more efficient for the rest of your life, right? And then that might actually kind of increase your reserve capacity and then make you feel more energetic for, the rest of your day and week and life. So does that translate to the situation between the monk and the adrenalized person? I'm not sure.
Yeah, because you said the science would say they're actually burning less in the Zen state, and then it's a very trending, popular thing to do. And I know there's some science that says that it's people feel better, for example, who meditate, but that might be purely psychological and may not be connected necessarily to your energy efficiency.
Yeah, there's some good research showing that meditation and maybe there's more research done on mindfulness. And that has, I think, objectively quantifiable effects on symptoms, and for patients with different conditions and, esoteric or not just subjective experiences. People feel better, quality of life, can be improved, but also the body seems to work better if you go from being in a state where you're not well, you engage in this kind of practice, you follow this kind of training, people start to sleep better, they start to have fewer symptoms of anxiety and depression, but then also the digestive system works better. Maybe it has direct effects on the heart, on the ability to control glucose and glycemia and things like that. So there's some real physiological effects there. Whether that's driven by energy, that's our working hypothesis, right? That energy is the link or the connection by which the subjective stuff that we experience actually makes it into biology.
So someone, staying on this thread of the psychological, so someone who is depressed, one of the main symptoms is tiredness or lack of energy. It might even be like literally what the psychologist or psychiatrist might have as one of the hallmark symptoms. What's the chicken and the egg there?
Yeah, that is an important question. And I don't think we know. We've all experienced, events in our lives that just from minute to minute drain us and make us feel like we don't have energy. It's relatively easy to imagine that you have, stuff that happened to you and then cumulatively, right, it activates your stress responses, you secrete stress hormones, your heart rate is higher. And chronically, when those things accumulate, the science shows that then this is a risk factor. You're more at risk of, developing depression and major depressive disorder. So it could be that, the things we experience, make it into the biology and then you end up stuck in that state, right? And then that state, we've learned, or psychiatrists have learned to label it depression. We've put a label on it, but it's really kind of chronically depressed energy that then manifests in all of these symptoms, right? Like loss of interest in things, loss of libido, and all of these other hallmarks of depression. So depression is really a catch-all. It's a very broad net, right, to capture a very complex state of the human mind, which isn't the same for everyone. Everyone's depression is slightly different. Or is it something biological? Could there be something in the body that you have less energy and therefore you're more vulnerable to those experiences, or you're stuck doing something in your life that you really dislike, and every day is a is a grind because you're just not energized by the life or the work you have. But could there be something biological that kind of predisposes you to this? I think it's quite possible.
Yeah, you see that with people who are highly, let's call it, using my term, adrenalized, celebrities, athletes, soldiers, and then they go to a non-adrenalized environment. They can really get in a funk, like it's a big transition.
Yeah, the extreme is labeled bipolar disorder, right? But I think a lot of people have experienced this to different degrees, where you can be super adrenalized like during the week, and then the weekend is really difficult. Or during the day, you feel fired up, right, at work doing something, and then at night you feel totally depressed, and you're not sure what to do with your life. These kind of fluxes from high energy to low energy is, I think, very normal to some degree. Like everything has a cycle in life. We sleep and then we're awake. This is maybe the most drastic kind of example of cycles. You can't be on all the time. Like even if you think exercise is good for you, which it is, if you go on and you run nonstop for 12 hours a day and you haven't trained right to do this, then you're going to crash. The reason exercise is good for you is because after you take time to recover. This is where that's very clear. The health benefits of exercise, when you actually make more mitochondria, what we were talking about earlier, is during the recovery phase. It's not while you're exercising, is the night after, the day after you've done like a good workout, and then the body says, ooh, I better prepare for next time this happens. But there needs to be this rest, kind of this quiet period where the body can regenerate, make more mitochondria and so on, which might be where stress reduction and, mindfulness-based training and meditation comes handy for some people, who live at a very high level, adrenalized most of the time, and then having this kind of quiet restorative period, might be the time when the body feels like, now it's safe. Now I can recover and recompose. And then you can go up and, work at a very high level, adrenalized. But if you never have this dip, right, I think it's the same way if you don't sleep enough, right, and you don't have this daily dip, then it can be harmful.
Maybe that's, just pure conjecture, but building on what you've shared, maybe the mindfulness part, maybe it helps you regulate these periods because you're not as sort of triggered on the upside or downside. Mm-hmm. Because we know people who exercise are more energy efficient and have more energy. Right? These things are perhaps connected. And again, those people who sleep for the minimum time, again, their mood is better. They have more energy, and there is some sort of restorative effect or something that happens to your mitochondria that makes them, again, more efficient producers.
Most likely, whether it's, energetic efficiency in the mitochondria, whether it's something that happens at the organism level, right? Like the organs talk to each other in a more efficient way and there is better coherence. So we don't really know where that happens, where that gain in efficiency is happening. But I think it's pretty clear that is somewhere where there's room for optimization.
You talked briefly about the stimulants, right? So if somebody's having 7 coffees a day, in effect, it's making you feel like you have more energy. Is it giving you more energy?
It's definitely making you feel like you have more energy. And there are, stimulants that are even stronger than caffeine that can make you feel that way. But I think it's pretty clear that you cannot be on that forever. Like you need to stop drinking coffee during the night and you can't be on strong stimulants, for a long time. Otherwise the body crashes and the mind crashes. So I'm not sure we know actually. Does it give you more energy? Does it just make you feel like you have more energy? I would think it makes you feel like you have more energy, and it's, tapping into some reserve somewhere. There was a great piece in the New Yorker on this by Nick Baumgarten, where he kind of highlights the high level questions there and, talks about things like that.
So, young kids are literally bouncing off the walls and, the 90-year-old is most are pretty sedentary.
Yes.
What happens there?
Yeah, we have a 2-year-old at home. So
Yes, you know.
yeah, the level of energy, like after dinner, we're sitting around the table and, or the grandparents sit with us after dinner and they're in their 70s and they're definitely, quieting down. Noah's running around the table. That's his most active time of the day almost. Yeah, definitely there's a gradient of energy and kids are definitely full of it. We don't really understand, why this is. There's good evidence that the mitochondria change as we age, and maybe the ability to transform energy changes as well, right? When the immune system gets activated, and then you feel this thing that you feel tired, you want to sleep, and this process called sickness behavior. I think we can think about aging maybe in the same way. The body knows, right, that there's kind of a limitation to how much energy it is available. And then as a result of this, the body says, okay, if I am to remain healthy, I better reduce how much energy I'm going to spend. So let me reduce the muscle mass, which is a huge energy consumer. Let me reduce the size of my brain, for example. With very advanced age, the brain shrinks a little bit, maybe to conserve energy. And let me not be as vigorous. All of these features that we associate with aging and frailty might be kind of a wise move by the body, right, to minimize how much energy it's spending because there's less available.
Switching topics just slightly, are there any medication, there's a lot of conjecture about the benefits of, say, NAD or metformin. I mean, have you ever thought about this and, how true some of this might be because there's ongoing research into it? And does it affect energy?
Yeah, there's a lot of research ongoing about this. There's a lot of interest to, find a pill eventually that, can cure aging. So I don't think aging is a disease. I don't think we can cure it. The body is wise, and there's like 1.5 billion years of evolution under the hood to maximize energy efficiency. There's really good evidence. Every living creature on this planet kind of works almost at their optimal efficiency. Can we hack the system and kind of make things better? I tend to doubt it. Maybe that's just my bias. I tend to think that the body is tuned really well, and mostly we can do things to derail it.
And what about just food? So, for example, lots of research seems to indicate Mediterranean diet, more green, less meat, has a longevity benefit. Might it even have an energy benefit, in your opinion?
Yes, totally. Yeah, very good evidence. Eating less meat is not only good for the planet and reducing our carbon footprint, but also for the body. And maybe for the same reasons, because if you eat more lipids, right? Like think about oil and avocado and oils and fats. This has to be burned, has to be metabolized through your mitochondria, which is the most efficient way to source and to transform energy in the body. The alternative is to burn sugar, and sugar can be burnt without oxygen through glycolysis. Now, eventually in the body, you have to use oxygen at some point, but the extreme ketogenic diet, which is like no sugar, mostly or almost exclusively the body consumes lipids and proteins. And that really forces energy flux through mitochondria. That might be why it's good for some disorders and some disease states. There's good evidence that cutting down on sugar and eating more lipids is really healthy, especially for people who have some, psychiatric issues or some cardiovascular or some, diabetes, metabolic disorders.
Is somebody who is obese not as energy efficient?
So that's a long-standing theory, right? That if you're not as efficient, then something's wrong in the body, and then that can lead to weight dysregulation and to accumulation of fat. The same way that exercise makes you more efficient and the downtime. Something else that makes the body more efficient is not eating too much. There's a lot of really good science there that if you're hungry once in a while, it tunes things in the body in a way that makes it more efficient. And it's actually positive for the mitochondria, and that it has positive health effects.
So Martin, if there were, for our listeners, 3 things you would do to optimize your energy, given the myriad of discussion topics we've covered, what would be your top 3 things that folks should focus on to maximize your daily energy?
So one is whatever you can do to breathe harder is generally good for you. Going up the stairs, walking and choosing those kind of options. Number 2 would be not eating too much, spending times, of the day being hungry is just an important stimulus that triggers quality control processes in your body and, clears out the things you don't need, the old mitochondria. You make new ones that are, healthier probably. And the third piece is probably engaging with people, engaging in something that has meaning for you, right? That brings purpose to your life on a daily basis. So it's really clear that it makes people feel like they have more energy.
Well, that's amazing. Really appreciate your time. This was super fascinating and really complementary to everything we know also about longevity. So it's of no surprise to me that, many of the things we know about longevity also correlate with energy and maximizing energy. So I appreciate your time today.
My pleasure. Thank you for the great questions.
That was Medcan CEO Shaun Francis in conversation with Dr. Martin Picard, professor of behavioral medicine at Columbia University. Follow Dr. Picard on Twitter at mitochondrial. That's MITOPSYCHOBIO.
We'll post episode highlights and links you can visit on our website, eatmovethinkpodcast.com.
Say hello and send us a tip or a suggestion by emailing us at info@eatmovethinkpodcast.com. And follow Medcan on Twitter and Instagram at MedcanLiveWell.
Eat Move Think is produced by Ghost Bureau. Jasmine Ratch is managing producer. Social media and strategy support is from Chantal Gertin, Andrew Imex, and Emily Bozek. Executive producer is me, Christopher Shulgin.
We'll be back soon with a new episode examining the latest in health and wellness.
This podcast is intended to provide general information about health and wellness only and is not designed or intended to constitute or be used as a substitute for medical advice, treatment, or diagnosis. You should always talk to your Medcan healthcare provider for individual medical advice, diagnosis, and treatment, including your specific health and wellness needs. This podcast is based on the information available at the time of preparation and is only accurate and current as of that date. Source information and recommendations are subject to change based on scientific evidence as it evolves over time. Medcan is not responsible for future changes or updates to the information and recommendations and assumes no obligation to update based on future developments. Reference to or mention of specific treatments or therapies does not constitute or imply a recommendation or endorsement. The links provided within the associated document are to assist the reader with the specific information highlighted. Any third-party links are not endorsed by Medcan.